Good morning or evening or afternoon, whatever time you happen to be at. I'm going to show you how to do some of these things on the calculator. This is a review of class the other day in case you missed it. Okay, so what we want to do here is find the equation of a line tangent to a graph at a given point. So what we really need to find is the slope of this curve at that point. What I'm looking for number 65 is, what is f prime of negative 5? Okay, so here's how we find f prime of negative 5 on the calculator. So I'm going to just come here, a few ways to do it. I'm going to go to math, and then 8, numerical derivative, and it gives me the pieces to put in. I want d dx. I want to put this function here, x divided by x plus 4. And then I need to tell it this is the equivalent of this negative 5. I need to tell it what value to find it at. So negative 5, I press enter, and there I go. So it told me, come on, it's supposed to come over here. There we go. It told me 4.00004, but my brain says that means 4. So this means that f prime of negative 5 is 4. Okay, and then I just have my equation. So I have y minus 5 equals 4x plus 5. And that's the equation we're taking to the curve. Okay, so that's just how I found f prime of negative 5. Okay, alternately, I put that equation in this function here, and instead I can do, again, math 8, but that one dx still. But instead of retyping the equation, I already have it in y1 over here. So I go to vars, yvars, function y1, and that'll put y1 there, which is this right now. Then I can do negative 5 again and enter, and it'll give me the same answer. Okay, it's just using this function as a variable. Okay, so I've switched pages now. Now we're going to use these calculators to help us find critical numbers, really by graphing derivatives. So what I've done is I've taken this function here, and I've graphed it. Okay, you can see it's in y1, and I'm just going to show you how to graph the derivative. So I go to y equals, I go to y2, and again I go to math 8. Okay, and I'm going to put this all in, and it's d dx of that function. So I'm going to use that vars yvars function y1. So it's the derivative of y1, and instead of at a specific point, I want to do it at x. So it's at x equals x. So this is the equivalent of writing f prime of x instead of f prime of negative 5, like we did before. And now if I press graph, it'll start to graph this derivative, and it takes a really long time because for every point, it has to really plot 2 points of the derivative, find the slope between them, and see what's happening. So you can see that there's the graph. It's a cubic. I see a parabola. That's good. Okay, and from up here I can see it's still working. So I'll wait for it to finish. And the question said, where are the critical numbers? So I can see the critical numbers, but maybe they're not nice numbers. So I can do the same things I do all the time with graphs. We can do second calc zeros, excuse me. So I want to find the 0. And I want to find the 0 of the red curve, right? So I'm going to go up to the red curve, and I got to go to a left bound, and I'm not sure where the cursor is. There it is. Okay, so I go to the left of it, I go to the right of it, I make my little guess, I press enter, and it tells me that x is equals negative 2. So that's a problem, much easier done by hand, but that'll give you that 0. And since I see that the derivative is positive here and negative here, positive to the left of it, negative to the right, I know that it's a relative maximum. Okay, so that at -2. So that's a way of looking at these and doing them on the calculator. Okay, and that's how we graph a derivative. So that's all I have to say about that. Thank you. Bye.